Welcome fellow developers to the full stack development module. In this course, we'll embark on an exciting journey into the world of Solana, where you will master the powerful combination of React and Anchor to build, test, and deploy your very own decentralized application on top of Solana. Right, so in this part, we'll delve into the heart of Solana's smart contract development using Anchor. You learn how to create a robust increment program, a simple yet essential smart contract that will serve as a backbone of our decentralized application. Together, we'll walk through the entire process from writing secure, efficient code to thoroughly testing your smart contract and finally deploying it on Solana network. We'll use DevNet for this purpose. Then in part 2, we'll shift gears to the front end, where React will take the stage and you'll discover how to seamlessly interact with your deployed Anchor program. Bringing your decentralized applications to life through hands-on coding sessions, we'll build a dynamic React-based interface that communicates directly with the Solana blockchain, allowing users to engage with your program in real time. By the end of this module, you'll not only have a fully functional dApp and running on Solana, but you'll also gain the skill and confidence to create even more complex projects in the future. So, gather your coding tools and prepare for an adventure in full-stack Solana development, where innovation meets the speed and scalability of the blockchain. Let's begin our journey one line of code at a time. So here we are going to follow the official guide of Solana, the full stack Solana development with React and Anchor. You can head over to solana.com/developers/guide/get started/full stack Solana development and you'll get the guide. So what we are gonna do in this session, in this module, we'll be using Anchor, Solana CLI, React, and Wallet Adapter. We'll be learning how we can build a Solana program in Rust using Anchor. We'll be testing Anchor program, deploying it to the Solana development, and in part 2, we'll be creating React app from scratch and connecting your React app to the Solana program. For our environment setup, we need these 5 dependencies. Those should be installed in your system already. If not, you can watch my tutorial. That's the previous one, the part of the whole course, right? So you can download it from there. We just need Node.js, Yarn, Rust, Solana CLI, and Anchor. We'll be using AVM 0.29.0 for this. If you want to switch to this version, you can just use AVM use command and then specify this version right here in your command prompt. Yep. And once you have installed everything, you can just check the versions using these commands, right? After that, if you don't have the Solana keygen, you should generate a new one. It will just set up a new wallet for you in the localhost itself. You can also set the configuration to localhost. And then you just need to Solana test validator for setting up a local validator. This will act as a dummy Solana blockchain cluster on your local net. Let's do this. Let me open the WSL as I am using Windows 11. Yeah, I'll go into the root directory and there we'll just run Solana test validator. We'll just wait for it to initialize. As we can see, our validator is running. Right, so that's all we need. So when we run the validator, it gives us a huge number of Sol in our account and we can airdrop more using these commands, right? So now let's set up our Anchor project. We'll name it as Counter project. Let me open a new command prompt and in here we'll open the WSL. I'll do Anchor in it and then project name we are gonna name it as Anchor counter_PR. As I'm using some previous versions of Solana, so I just need to add the Solana program version to 1.17.34 so it will work correctly. We'll just need to head over to our project, that is counter_PR, and then execute this command. It will just downgrade some dependencies. Right, so we are ready to go. We can check our project. Is it working correctly or not by using the command anchor build. Build will just compile all the dependencies and build the project, right? So finally, after building and compiling a ton of dependencies, it is successfully built. And you can see it has finished in 2 minutes and 41 seconds. Right. So we have got here. Right. Now, if we go ahead and open it with VS Code, yeah, as we can see in our program directory, in the source, we have the lib.rs file. That's the main file in our program is contained. In here, we have a sample program which we just built. It basically says, firstly, we are importing the anchor lang, and thereafter we are declaring the program ID of this program. And then there we have the derivative of program. All the functions of this program will be in this module, mod count_pr. We are importing all the super modules. We are importing all the modules from the super keyword. And thereafter, we are just initializing a first initialize function that takes a context that we have defined here. That's the struct initialize, and it will throw a result, and it just for now prints the success. In here, we will just install the Rust analyzer. If you don't have, you can install it. I'll just reload the window. So yeah, this was the sample content which is included in the sample file. Now, we'll just make our custom project. Firstly, let us have a look at the test directory. In here, we have the test file also for this program, right? What we are doing is just importing anchor and our program, that lib.rs file, and thereafter we are importing the counter PR from the target types counter PR. That's the JSON file of the program. In here, we are importing anchor and then program and then counter_pr from target types and of counter_pr, right? In here, we are importing firstly anchor from Coral XYZ, thereafter program also from Coral XYZ, and then we are just importing the counter PR from the target types. Yes, so in this test, we are just describing it for counter_pr, and we are just setting up the provider to anchor_provider.env, and then we are declaring the program keyword as the anchor workspace.counterpr. We are just setting up our program here, and is it initialized or not? We are checking it here by program.methods.initialize.rpc, and then we are just printing out your transaction signature. This is the transaction. Okay, so for now, let's go ahead and run anchor test here. So as we can see here, our test is passed and your transaction signature is this. We have just deployed this smart contract in this program to our localhost blockchain cluster. That's right here. Yeah. So what the test actually does, it creates its own blockchain cluster. So as we can see, this blockchain cluster has been killed. Now we'll write our very first program in Rust using the anchor. We'll write a counter program in which we'll be declaring the initialize instruction, the increment instruction, and some states such as initialize and increment and counter. In the Solana programs, we use instructions for functions. We use the keyword instruction for functions, and we use structs and data types as the states, right? Let's go ahead, and when we build this file, it will just change the program ID, so we don't want to have any changes. So we don't want to care about it, right? In here, we are just declaring our program. We are just importing all from the super keyword. And now, before reading out these instructions, let's go ahead and check out these states. We have declared 3 states. Those are initialize, increment, and we have counter. In the initialize, we are giving it a lifetime of info, and in here we are using the derivative account mute, which will make the account mutable basically, and we are declaring a user variable which will take the signer info. Info is basically the lifetime of the variable, and here we are just putting a derivative of account in which we are specifying we are creating this account using the init keyword. Thereafter, we are specifying the payer is the user, that's the signer itself obviously, and then we are giving it a defined space, how much space it should take on the blockchain. We are giving it 8-byte discriminator plus 8-byte for uint64, right? Thereafter, we are declaring the counter variable which will take the account, And then we have the system program, which is the type of program with lifetime of info, and we have the system here, right? So this is the initialize struct, and then we have our increment struct, which just have a counter keyword that basically is the data type of account. And also we are declaring it as mutable, from which we can easily mutate the account details, right? And at last we have the counter struct, which is also the derivative of account, in which we are just declaring the count variable to be the u64, right? So now let's head over to both of the instruction and let's discuss in detail about them. We have the initialize function, which basically takes the context initialize, which we just mentioned here. So now let's look after both of our instructions. Firstly, we have the initialize instruction, which takes the context of the initialize struct, which we created here. And in result, it gives nothing right now. Here we are declaring the counter keyword, which is the reference of account counter, and we are passing the reference of context.accounts.counter, the counter variable that we declared. And thereafter we are just printing out using the message keyword the counter account created, current count, and we are just passing this variable to counter.count. Okay, and at last we are just giving it as a success using the OK keyword. Now in the next instruction, that's the increment instruction, what we are doing is we are just taking the context increment and just passing the result. So guys, we have another instruction here, the next one, that is the increment, which just takes the context of the increment state struct, which we have declared here. Increment struct as just the attribute of mutable account and the public variable counter, that's the account data type, and then we are just passing the result back. And thereafter we have declared the counter variable in the mute state so that we can mutate it, or we can change or alter its state. We have this reference this mute state and fetch to the counter from accounts of the context, and thereafter we have used the message keyword to print out the previous counter, and we have passed the counter.count variable in it. Thereafter we are just adding a checked add into it. We are just fetching the counter.count, and we are just using the checked add operation and unwrapping it to add the value of 1 to it. And then thereafter we are again printing the value of counter, the increased value of it, and lastly we are just passing the OK keyword to result the success of the function. Right, so that was all in this program that's going to be happen. We can close it up, and here's our test file. We can use this test here. Firstly, I'll just clear up this terminal and let's run anchor build. We'll just wait for it to be built. Yep, there it is. Now we can deploy it to our local cluster. As you can see, our cluster is on. Yep. We can see our program ID up here, right? Our deploy is success. Now, what we have seen in this program, let's go line by line to it. We have seen the derive accounts attribute that tells Anchor to generate the necessary serialization and deserialization code for the accounts. We have seen the account mute attribute that tells Anchor that the account is mutable. We have seen the user signer info with the info lifetime. The user is type signer that signs and pays for the transaction, and as we know, info is the rest lifetime. And we have seen the account init attribute that just tells Anchor that the account that will be created, and we have seen the specified the pair is equals to users property that tells Anchor that the account is going to be owned by the user, and we have declared the space that tells Anchor how much space we are going to be allocating towards that account. At last, we have two more variables, counter and system program. Counter basically is the type of account with the data type counter, and the system program adds a constraint that the system program must be in the list of accounts for the transaction. Right now we are almost ready to build this program, and we have already built this program. So we have already built this program and we haven't tested it out RN, though we can do it. But if you want to test, you just need to run this command, anchor test skip local validator. Skip local validator command will use this existing local validator and won't deploy a new one, right? So it will do it like this.